Fantastic. Hi guys, welcome to the demo session for Hadoop data science. Okay, we'll elaborate more on what exactly data science and Hadoop is. Yeah, first of all, myself Akrit. Yeah, here is my brief details, guys. I'm a certified Hadoop professional as well as a certified data scientist too. I've been working with Cloudera since past 4.5 years. Yeah, since its inception, and was very fortunate enough to be the part of the founder of Hadoop, that is Duff Cutting. Yeah, right now he is with Cloudera. Previous to that, he was with Google, from where Hadoop took its birth. Yeah, so basically, I have worked with Hadoop analytics and big data since past 3.5 years. Complete research was going on into that, and previous to that, we are busy building tools onto Hadoop, like Impala and all, right? So I specialized in several NoSQLs also, like HBase, MongoDB, Cassandra, and even certified in HBase too. Yeah, so HBase, MongoDB, and Cassandra are nothing but NoSQLs, correct? So this is my brief history, guys, and I've applied Hadoop and big data across domains and have dealt with clients and delivered products accordingly, right? Have registered 2 patents on to analytics also. Have a dual wind algorithm registered on my name. Yeah. So let's get started. Module 1, motivation in basics. Okay. So today it will be a very short session, guys. Okay. The first 2 sessions will be very short. Okay. And then we'll move on with our daily schedule of 1.5 hours. Right? So today we'll go through to what is big data. Fine. What exactly we'll be covering it in our course. Right? What all Hadoop components we'll be playing with. Okay? And even the external Hadoop components too. Fine? Like Scoop, Flume, Uzi, Mahout, and all that. Right? I'll be sharing the syllabus also. So this complete batch, guys, data scientist batch, fine, we have divided into 2 parts. The first part is Hadoop, correct? And the second part is core data science. Second part is core data science. Fine? Hadoop as well as data science, right? Now what exactly Hadoop is? Hadoop basically is a framework to tackle big data. What is data science? Data science is basically nothing but analytics. You got to learn statistics for it. You got to learn some machine learning algorithms for it. Some NLP, data analytics like Bayesian, supervised, unsupervised learning techniques and all that. Okay? And a modern data scientist is basically integration of both of them, right? Hadoop plus data science, right? So basically a data scientist role is, it's kind of a statistician come a software programmer. He should be able to integrate both of these qualities well, right? Then only he can be a good data miner or a data scientist, right? So few people are not interested in statistics. For them, you should go only for Hadoop, right? It's a provision for them too. Those who are interested in both of them can go for both of them. Hadoop plus data science, correct? Now, let's move forward, guys. Big data concepts. Now, what is big data? Generally, people call big data as about 3 V's, right? It's generally called as 3 V's. That is volume, velocity and variety. I would like to even associate a fourth V to it, that is veracity. We'll discuss that later. Correct? Now, what is volume? Volume basically is nothing but volume of data which is piling up exponentially. Why? It's getting increased exponentially. The reason is because of the data feeder mechanisms. Because of data feeder mechanisms. Yeah? Because of the increase of smartphones and devices like that. Right? That's why the data is piling up like anything. Volume is increasing and increasing. Right? So the data is no more into the GBs. It's moving towards terabytes, petabytes, zettabytes and zettabytes. Correct? Because of the emergence of new techniques to input data and because of very small and handy devices, right? On the go, you can add a review, you can write a comment on LinkedIn, you can add a post, fine? You can write a Twitter feed, right? So, tons and tons of data is being created. Now, what to do with that data? Can I do data mining on that data so that I can add business to one of my client, right? Be it a bank, be it a pharmaceutical firm, be it an e-commerce, there are plenty and plenty of things that can be done with the data. Whether it's a transactional data, whether it's a historical data, depends. Correct? It depends. Fine. So basically, this huge volume of data is there. Fine. How I can use this data? Fine. And the main part is storage aspect associated with it. The main part, storage associated with it. Right? So storage is basically a domain from which companies like EMC Square, NetApp, Intel, these companies are making huge benefits because of the storage domain. Right? We'll come to that later. The next point, velocity. It's not just volume. Right? With the increase of volume, even the data is getting piled up with high frequency. With high frequency data like in stocks, how fast the tickering is happening of the stocks, right? That is not due to one parameter. That is due to several parameters. Fine, that particular stock indices is getting affected. Correct? So this is about velocity. Okay, high frequency data like in stocks, stock markets. One aspect of it. Now, this data is getting piling up, fine. With this, we have a frequent data also. So, let me give you an example. Before few months, there was an election in India. Okay, there was an election in US last year, right? So, what happened? Suppose an election debate. Okay, in any one of the news channel, a debate is going on. There is a speaker from party A, there is a speaker from party B, there is a speaker from party C. Right? Now, a hashtag is being created on a specific issue. Right? On a specific issue. Now, on that particular issue, public's sentiment is positive towards which particular party? Fine? Public sentiment is positive or negative towards which particular party? How can we decide that? Basically, a taxonomy is being created. Okay? So, suppose say someone is writing a Twitter feed, in that there is a comment called awesome. So awesome reflects a positive sentiment. Okay, fine. So like that, we do sentiment analytics. We can do a sentiment analytics on live Twitter feeds that's going on. Okay, so this is just a small and a sample example that a news channel would use, that whether public sentiment is positive or negative towards which particular party. Yeah. So live streaming can be done. Fine. So this is what? Velocity. Now the biggest USP of Hadoop is variety. Okay. You have structured as well as unstructured data, and you can do analytics onto unstructured data also. You can do analytics onto unstructured data also. Right? It's not the structured data on one, you can do the processing of the data. No. You can do it onto unstructured data too. Right? Like emails. Right? You do write, I am fine. Correct? You don't write, I am fine. Fine. So email is one of the unstructured data, guys, machine data, right? So there was a client called Allstate. It was an insurance giant, right? So for Allstate, what we did, they had given approximately 10 terabytes of a driving patterns for a particular data. The 10 terabytes was completely onto the driving patterns of their clients, how their client used to drive on road. Fine. So the data was all latitudes, longitudes and all that, time. So let's say the client called Roger is driving from point A to point B in a specific time, right? Let's say the distance is x, correct? So x divide by time. X divide by time, we call that as velocity. We call it as speed. Now if that speed limit is crossing the speed limit of that freeway, right, or that particular road, fine. If continuously that kind of a pattern is being observed in Roger, fine, then Roger is being termed as a rash driver. Yeah, Roger is being termed as a rash driver, and more penalty points are being laid down on the premium being paid for that insurance. Yeah, more penalty points were being laid down on the premium, right, for the rash driver. Okay, so this is one of the smallest sub-module that we prepared it for Allstate, right? So you can do analytics onto machine data also. You can do analytics onto unstructured data like emails, Twitter feeds, Facebook comments, anything. Okay, so this is, guys, the general life cycle that goes on in any big data project, right? You have the data present, fine. You got to perform analytics out of it onto that data, fine, do the data processing, and then drive decisions out of it so that it can add business value to my client. Finally, it should add some value, right? Business value. So here are some of the case studies, guys, that we'll be seeing it throughout our course. Into retail, right? Pharmaceutical, banking, transactions, healthcare, telecom, and finally the manufacturing. Okay, this manufacturing case study we'll be completely focusing on our data science course only. It won't be covered into Hadoop. Rest all, it will be a merger of both of them, right? So challenges in big data: no proper understanding of the underlying data. We don't know how the data would be. What would be the data type? Whether it would be alphanumeric, whether it would be with image, video, I got to process it anyhow. Fine. Second aspect is storage. How to accommodate that large amount of data? 1 petabyte of data is there. How should I accommodate that? So that I can have data availability there at all point of time. I should not be in a fear of losing the data. Okay. And performance. To process that large amount of data efficiently and effectively. How can I process that large amount of data efficiently and effectively so that I can increase the performance out of it? It's a very big aspect, performance. Right? So, how to process that large amount of data? So it's not just volume or storage, I want even performance out of it. Correct? So, the case studies that we saw, guys, okay, healthcare, telecom and all that, right, banking transactions. Before few months, I had been to London, right? So over there, when I entered the mall, right, there was a projector screen that was being shown in front of us. Okay. So as soon as I entered, right, it was a small supermarket. That person standing in front of the projector, right, he showed me the direction that this is the particular product that has come of a particular category. You can go to this particular counter. Fine. Now, it was the exact product that I was looking for. Maybe it was a coincidence. Maybe it was some analytics being driven at the back end. So I inquired, and basically they scanned my card of that particular supermarket. Right? They scanned the card of my supermarket. Basically, they had identified that most of my transactions in that particular season, as I had stayed long in London, fine. So most of my transactions during that particular season, it was March, April, right? March to June. Generally, the August is the summertime, August, September. What are my shopping requirements? What generally I do shop, right? So it had suggested me 3 to 4 products. And basically, even I had always shown liking towards fiction, right? So all the fiction related new releases, new books, new movies, correct? Where it was being kept. It was being kept somewhere in the counter number 9 to 11. So they had suggested also 9 to 11 counter number. That go over this particular counter number and you can get your new release of fiction books. Correct? So this is nothing but trend analytics that particular guy or the back end was being done. Right? So this is generally, guys, a traditional application. Right? So in the normal traditional application, what happens? You have a server lying at one place. You have a database lying at some place. You continuously depend on this particular thing, network. Network is a thing on which you are very heavily dependent on. Right? So how to avoid dependency on network? How to avoid dependency on network? Because in a traditional application, you continuously hit the data, you come back. Right? Suppose you write a select star from query, you hit the data, you come back. You hit the data, you come back. But I want to reduce my dependency on network. I want to reduce my dependency on network. Right? What can I use? If I want to reduce the dependency on network, I can use Hadoop. Hadoop basically works on the phenomenon called as data localization. Data localization. Data localization means sending your source code or your executable, sending your source code or your executable where the data is lying. sending your source code or your executable where the data is lying and running it over there. Correct? So this is what? This is nothing but data localization. Right? That is running your source code where the data is. Okay? So suppose say there is a client of Accenture. Okay? So they don't get a dedicated network line from application to the database. All the company's traffic has to go through the same line. Okay? Mark Zuckerberg cannot control the production of data. It's bound to increase. And the format also changes very often. Fine. You get unstructured data, plenty of hodgepodge of numerous data types. Right? So this is, guys, a statistical model that I have prepared it. Okay? I'll be taking up your doubts, guys, within another 5 minutes. Okay? So hold on. Just within 5 minutes, I'll be taking up your doubts. So let's say this is a statistical model. I've assumed that the network bandwidth is 10 Mbps. Right? Network bandwidth is 10 Mbps. And let's say I have the data size as 10 MB. Correct? The network bandwidth is 10 Mbps. So I have got 1 second. So 1 second is basically to go to the database. Again coming back, 1 plus 1, we have 2 seconds. Fine. 1 plus 1, 2 seconds. So the total round trip time, fine, the total to and fro time equals to 2 seconds. Fine. So the total round trip time equal to 2 seconds. So 2 seconds is to go to the data, coming back. For 10 MB, it is taking 2 seconds. For 100 MB, 20 seconds. 1 GB, 200 seconds. For 1 terabyte of a data, it's taking approximately 55 hours. No client can afford that. Right? It's approximately 2 days of a leave for the employees. Correct? So the observation is data is moved back and forth over the low latency. Approximately 90% of the time is consumed in the data transfer. Fine. So this is your conclusion. Achieving data localization. That is moving the application to the place where data is residing or making data local to the application. Correct? Fine. So there was a telecom client for whom I was working for. It was Ericsson, right? So basically they wanted to use Hadoop for the network management project. What was that? In telecom, everything is a cellular structure, right? Right now when we are talking by our cell phone, right? We are into a particular cellular structure and we move from one particular cellular structure to another particular cellular structure. Right? Suppose say we move from here to here, here to here. So when a person moves from one cellular structure to another cellular structure, right, signal is being transferred from one base station to another base station. Right? So whenever a person moves from one cellular structure to another cellular structure, we sometimes see a drop rate happening. Sometimes we see that call drop is happening. Okay? That is due to several reasons. There are several parameters associated to it. There is signal to noise ratio. There are some radiation patterns, frequency, right? So all these parameters were taken into consideration. Fine. And then we came out of the conclusion that by changing this particular parameter, the network coverage can be improvised. Customer satisfaction can be improvised. So these are some of the parameters, guys, that are being associated with Hadoop. Right? The same project we did it for Novartis. It was a pharmaceutical firm. We'll be doing that. And for healthcare, I would say it's a boon big data is a boon, I would say. Okay. Currently, the news came that IBM basically is trying to find out the solution for Ebola, right, with big data. Right? It's not just healthcare or pharmaceutical. It's basically even being used by Goldman Sachs, right? Morgan Stanley. Okay, they have started preparing the bench strength for recruiting data scientists. It's being observed in US, as I had been in US before 3.5 months back, where they were started preparing for the digital pods over there. And similarly, the same stuff they are trying to do it over here in India, right? So these are the things, guys, right? So what all things we'll be doing it in our data science? In our data science syllabus, guys, basically, we'll be doing statistics, right? Algorithms, Hadoop ecosystem, R, machine learning, NLP, and data analytics, right? So, stats, algorithms, Hadoop ecosystem, R, machine learning, NLP, and data analytics, correct? So, inside statistics, what we'll be doing? We'll be doing central tendency, variability and spread, probability, permutation combinations, right? Geometric, binomial, and Poisson distribution, normal distribution, correlation, and regression, right? So these are some of the topics of statistics that we'll be doing, guys. Algorithms, in which we'll be doing sorting techniques, hash tables, trees and graphs, right? And this is the Hadoop ecosystem, guys. HDFS, MapReduce, Hive, Pig, Scoop, Flow, Muzi, HBase, WebLeech, and Tika. Introduction to R. This is nothing but a statistical tool, guys. R is nothing but a statistical tool, fine, in which we'll be doing hypothesis testing, regression, manipulating data and extraction, correct? Then we'll be moving towards machine learning, NLP, right? And finally data analytics. So these are the topics, guys, that we'll be covering as part of machine learning, NLP, data analytics, okay? And we'll be learning our R and Hadoop integration. R Hadoop integration. So what is R Hadoop? Doing complex statistical computations at scale, right? Hadoop is well known for doing parallel computation, right? R is well known for doing complex statistical computations, okay? So we integrate the capabilities of both of them, and we can do complex statistical computations at scale, right? We call that as R Hadoop, right? So R Hadoop is mostly being used by the data scientists, right? R is basically a tool. It's a statistical tool. You can call it as a competitor of SAS. Okay, SAS has been used since decades for analytics and all, right? R is basically a competitor to that. Correct? R is basically a competitor to SAS. Right? So this is our syllabus, guys. Right? And generally our training pedagogy, guys, is like we do first our practicals, then we move on to our theory part, and then finally we go to the comic part. Comic part attached to it. Okay, so what is this comic part? Comic part is like our comic book, right? Here it is. You can see this. This is like our comic book. So for each module, we give a comic book like this, so that at times for interviews, for for certification questions, all that, okay, you can just refer this PDF. It's a simple 5-pager PDF which will cover your entire concepts of HDFS, okay, in brief, right? And apart from that, guys, after every 25% completion of the training, we conduct a test. Right? We conduct a test. So we have day 1, 2, 3 and 4 test papers. Total 4 test papers. And at the end, finally, we have a 90 question and answers Q&As of Cloudera. Fine. Apart from this day 1, 2, 3 and 4 test papers, we have 90 Q&As. So approximately 200 to 250 Q&As we'll be discussing. Right? Related to the interviews, related to certification. Okay? So that in future, if you want to crack a certification, you can crack it very easily. Right? So before proceeding, guys, I would like to show you guys one slide. Fine, and then I'll be taking up your questions. So sometimes people do have doubts when they come from different backgrounds. Yeah, they are skeptical that if I'm not from Java background, if I'm not from .NET, if I'm not from C, C++, can I learn Hadoop? Yes, you can. Okay, and don't worry, we'll be covering the prerequisites also. Right? Whatever prerequisites are required, we'll be covering that also. Okay, so we assume that you come from a fresh background, at least you have just some logical thinking towards programming. That's it. Okay, so please read this slide, guys, all of you. Okay, and I'll be taking up your questions one by one. So please click on the yellow colored hand symbol, guys, those who are having questions. Okay, those who are having the headset, please click on the yellow colored hand symbol, or you can type your question in the question box, your wish. Yeah, please click on the yellow colored hand symbol. So let me first come to Barsha. Yes, Barsha, please unmute yourself. Barsha Shrestha, please unmute yourself. You have muted yourself, Barsha. Please unmute yourself. Yeah.
Let me ask in a while.
Yeah, go
Give
ahead.
me some more time.
Okay. You take your time. Those who are having questions, guys, please click on the yellow color hand symbol. Or you can type your questions in the question box. People who doesn't have any programming background also don't worry. Okay? Because I'll be covering the prerequisites, but you got to work somewhat harder than the rest of the folks. Okay? It's achievable because our folks who are even from testing mainframe background, they were able to achieve it. Yeah? It's not a big deal. Only some of the basic Unix commands are required and some of the basic core Java concepts are required. Okay? So don't worry, I'll be covering that too. Okay? So it's kind of only 5 topics of Java is required, okay, to which you need to devote some time to. That's it. Okay? So I hope you guys have read this slide. Let me revise this slide for you. Right? Suppose say someone is coming from a database background. Okay? Is proficient in writing SQL, trying very hard to optimize queries, but not able to do so. Moreover, is not a Java geek. Right? He doesn't know Java. Will that solve his problem? Yes. It can use Hive. Hive basically uses HQL. Hive uses Hive Query Language. Yeah, it's like SQL. Fine. HQL is approximately like SQL. Okay. Hey, Hadoop is written in Java. I'm purely from C++ background. How can I use Hadoop for my big data problems? You can use Hadoop pipes. Right? Fine. It's an API, external library that you got to import it. A person who is coming from a totally non-IT background, doesn't know coding, doesn't know testing, nothing, knows only statistics, a business analyst or a data analyst, he can use Repay or he can use R and Hadoop, Hadoop. Okay. All the Cisco, Juniper people, right? The networking guys who are using scripting a lot, Python, Scala, Ruby, right? You can use Hadoop streaming. So most of the times in Cisco, if you will find openings for Hadoop, it will be into Hadoop streaming. Okay. You will see this too. Right? So anyone coming from any damn background, sooner or later has to deal with big data. Sooner or later has to deal with big data. No doubt about that. Okay? No doubt about that. Right? You got to deal with big data for sure. Right? So this is about Hadoop. Fine. A person coming from, say, database, right? Oracle, if they want to move the data to HDFS, HDFS is what? Hadoop storage. They can move that data and work on that data too. Fine. So there are several things that are associated with Hadoop ecosystem like Scoop. So if I want to work on Oracle data, I can use Scoop to transfer the Oracle data to Hadoop data. Hadoop database, that is HDFS. Hadoop storage, I would say. Okay, that is HDFS. That is, we call it as Hadoop distributed file system. Yeah. So if I want to tell about Hadoop, guys, what I'll tell? Hadoop is basically consisting of two core components. Hadoop consists of two core components. Those two core components are HDFS and MapReduce. HDFS and MapReduce. So what is HDFS? HDFS is Hadoop's own storage. Yeah. HDFS is Hadoop's own storage. MapReduce is Hadoop's own computation framework. Yeah. MapReduce is Hadoop's own computation framework. Correct. So this is Hadoop's own storage and this is Hadoop's own computation framework. Fine. So we call Hadoop as HDFS as Hadoop distributed file system. Hadoop distributed file system. So basically Hadoop works on a master-slave architecture. Hadoop basically works on a master-slave architecture. You have one master and you have several slaves associated to it. Yeah, you have one master and several slaves associated to it. Fine. So HDFS also has a master. MapReduce also has a master. Okay. Hadoop's speciality is it works on a distributed architecture, right? So there is one master machine, right? And there are several slave nodes. Okay, this is your master, these are several slaves. Correct? Master slave, master slave. Fine. So this is about your master slave architecture. Got it? Right? So let me take you to the brief of Hadoop, guys, and then again I'll be taking up your questions. As I told you, Hadoop works on a distributed framework, guys. That's why it provides scalability in terms of storage, performance, and I/O bandwidth. Okay. If I increase the number of machines, if the number of machines increases, hard disk increases, storage increases, RAM increases, performance increases, capability to take the input and process out the output increases, so IO bandwidth increases. So these are the three aspects on which Hadoop provides scalability. Okay, and there is other characteristics associated with Hadoop, that is fault tolerance, open data format, flexible schema and all. So what is fault tolerance? Basically, suppose say you have a file. Let's say the file size is 1 TB. Let's say the file size is 1 terabyte. You have kept the block size as 64 MB and the replica factor as 3. In Hadoop, when you start loading a file, guys, suppose say we want to load any data onto Hadoop, you got to mention 2 parameters. Always you got to mention 2 parameters. That is block size and replica factor. Block size and replica factor. So what is this block size? Basically, this block size is, when you specify the block size, you start chopping this file into several blocks. So depending on this particular block size, this file gets sliced and chopped into several blocks, and each block is being replicated thrice. As you have set the replica factor as 3, you can set it whatever you wish. Fine, depending on your cluster size and your client requirement. Okay, so as you have the replicas present, fine, you have data availability at all point of time, because even if one machine goes down, even if one of the slave nodes goes down, you have the block present over here as well as here. Yeah. So data availability is there at all point of time. We call Hadoop as machine agnostic, machine immune. Reason? Even if one of the machine is going down, we have the availability. Correct? And these are some of the other characteristics associated with Hadoop, guys. We will see that when we start doing our map reduce and all. Open data format. What is open data format? It does not understand after dot what it is, whether it is a .txt file, whether .pdf, whether .jpeg, .plc, whatever. Right? And this is the brief history of Hadoop. Right? Hadoop basically came from Google's white paper. Duff Cutting was a scientist, was working on the white paper. Fine. He was working basically on a page indexing and ranking algorithm. Right? At that point of time, his child was playing with a toy. It was elephant. That's why wherever you see big data and Hadoop, you'll see a small elephant there. Right? So Hadoop was just on paper by 2004. It came from Google. But Yahoo was the one who brought Hadoop to the market. This was the experiment being performed by Yahoo, July 2008. And I was very fortunate enough to be the part of this experiment in Yahoo. Yeah, it was a 4,000 node test cluster, which we achieved it. Okay, and still with MapReduce version 1, this is still an achievement. It's still a record. Right? So Yahoo was the one that brought Hadoop to the market. So in this there will be several projects that we'll be doing, guys. Fine, we'll be doing Hive, we'll be doing Pig. Okay? All these are all Hadoop only, but to deal MapReduce in different ways. Right? And there will be some data ingestion mechanisms also, like Scoop, Flume and all. And there is a workflow scheduler called Uzi. Okay? We'll be learning all of them in our Hadoop ecosystem. So those who are looking for Hadoop, guys, only for coding and development and all that, fine, you can go only for Hadoop. Okay? But if you have liking towards statistics, algorithms and all that, you should go towards data science also. It's pretty niche. Okay? And BBC has quoted that data science is the sexiest job of 21st century. Right? If you have liking towards it, you should definitely go for it. Okay? You can do some research onto data scientist job. Okay, and then figure it out, your options and your choice. Correct? Let me come back to your questions, guys. If you have any questions, please click on the yellow colored hand symbol, guys. Any questions? If you have, please click on the yellow colored hand symbol, or you can type your questions in the question box. Okay, so nobody is having questions. Good, right? So you can connect with the ERPXstreem team, right? Yeah, so ERPXstream team will help you in getting all the softwares installed. So we'll be providing you all the materials, the softwares and everything, guys, with lifetime access. Okay, so you don't have to worry about that. And as far as materials are concerned, we are king of all. Right? So please connect with the ERPXstream team, get enrolled, fine. And we'll be keeping today's session till here. Okay, tomorrow also we'll be having a short session. Okay, and from then on, our actual practicals starts. Okay, from the session 2, today was a demo session, tomorrow is session 1. Okay, and day after tomorrow, our actual practicals starts. So you need to have all the softwares and the materials by then ready. Correct? Okay. So at any point of time, guys, if you want to reach out to me, you can reach out to me at akrit@outlook.com. Let me write my mail ID over here. It's akrit for big data at outlook.com. Fine. Or for any logistical queries related to fees, server access and everything, please connect with the ERPXstream team. Right? The contact number and the mail IDs are being written in the mail that you guys would have gotten. Fine. Even the Skype ID is there. So the support staff will be available 24/7. Okay. Thanks a lot. It was a great question, guys, and indeed a good demo session. Thanks a lot. Bye-bye. See ya.